Now, this is a question on a Poisson distribution. So we have a manufacturing process that it's found that 0.3% of units are outside their faulty or whatever, right? And assuming a Poisson distribution, determine the probability that in a sample of 1500 units, we've 1, 2 and 3 questions then. So 1500 units anyway, first of all, n here equals 1500, right? And this is the Poisson thing here from the formula at the back of the exam sheet or wherever. Lambda equals n times p. Now 0.3%, that's not p, right? That's a percentage. So to get p from there, we're going to have to divide by 100. So the decimal point will go 1, 2. So you'd have 0.003, right? Because it's 0.3%. You know, it's 0.3 of 1%, right? So this is p. You know, because if it was 30%, then you'd have a 3. You'd have a 0.3 here, right? So 0.003 is p. So to get lambda, 1500 multiplied by 0.003, and that gives us 1500 multiplied by 0.003, 9 over 2, or 4.5 for lambda. Right, and just write it down there again, that's lambda. So that's a key piece here for the Poisson distribution. We have lambda is at 4.5 and n is 1500. Now, the probability that 4 units will be defective, right? The probability that 0 units will be defective is given by the formula e to the power of minus lambda. The probability that 1 unit will be defective is given by lambda times e to the minus lambda, and so on. The probability of 2 then being defective exactly with the whole thing is lambda squared times e to the minus lambda all over 2 factorial, right? So 4, the probability of 4 being defective is given by this formula, lambda to the power of 4 times e to the minus lambda all over 4 factorial. So we plug in 4.5 here and here. So that'll give us 4.5 to the power of 4 times multiplied by, right? So all of that, you could brackets around this one, multiplied by e to the minus 4.5 all over 4 factorial, which is 4 times 3 times 2 times 1. So we can stick all that in the calculator. 4.5 to the power of 4 on top, multiplied by exponential there, shift and the ln key gets you that, minus 4.5 all over 4. No, delete that and go shift up there for the, oh, sorry, I made a mess of that. Come back to the start now. 4.5 to the power of 4 multiplied by e to the power of minus 4.5 all over 4 factorial. And that gives me, where am I? 0.1898, right? So that's about 19% chance of getting exactly 4 units defective. It's, you know, of getting exactly 4 units defective in 1500, that's the probability there, about 19% or 0.19 rounded to 2 decimal places. Question 2 then, the probability that exactly 1 unit will be defective, we're going to use this guy here, right? So the probability of 1 unit being defective is going to be lambda times e to the minus lambda. Right, so we have lambda worked out. 4.5 multiplied by e to the power minus 4.5. And this is the probability of getting exactly 1 unit defective in a batch of 1500. 4.5 multiplied by e to the power of minus 4.5, and we get 0.04 with lots of 9s, right? So 999. So the 2 decimal places, really, you're talking 5%, or that's roughly equal to 0.05. The 2 decimal places, forget that there, right? Approximately equal to. So that's our probability of getting exactly 1 defective item in a batch of 1500. Now, part 3. Work out the probability that more than 2 units will be defective. Well, we've already worked out the probability that exactly 1 unit will be defective, and that's 0.05. We can also work out the probability of 0 units being defective. The probability of 0 units being defective is e to the minus lambda, and that's equal to e to the minus 4.5. We can easily work that out. E to the minus 4.5, and I get 0.0111, right, the 4 decimal places. And more than 2 units, if we get the probability of 2 units exactly, so that's going to be lambda squared times e to the minus lambda, all divided by 2 factorial, which is just 2 anyway. Right, we worked that one out. So we have 4.5 squared multiplied by e to the power of minus 4.5 equals that, and I'm going to divide that now by 2 factorial, and I get 0.112, right, 3 decimal places. So the probability that more than 2 units will be defective, well, that's the probability that exactly 1 unit will be defective there. This is the probability that exactly 0 units defective, and this is the probability that exactly 2 units be defective. So any other, if we add all these 3 together and subtract from 1, that gives us the probability of any other result, if you like, because this is the probability of exactly 1, this is the probability of exactly 2, and that's the probability of exactly 3. Every other possibility has to be a case where 2 or more units are defective. So our answer is going to be 1 minus 0.05 minus 0.0111 minus 0.112. Right, so put that little one through the calculator there. 1 minus 0.05 minus 0.012 minus 0.0111 and also minus 0.112, and I get 0.8269, and that there, sorry for the mess, is the probability of more than 2, of exactly more than, or if more, it's a probability out of 1500 that you'll get more than 2 units defective, which is approximately equal to 83% chance. Okay.